We have two different equations for the force of gravity. We have the mass of the object times the acceleration due to gravity, and we have big G, m1, m2 over r squared. First off, I just want to review to make sure we understand. Class R is not
radius.
We'll try that again. Class R is not
Radius.
It is
The center of mass.
the distance between the center of masses of the two objects. This is especially confusing because R sometimes is. Okay, remember, by definition, it is not the radius. It is the distance between center of masses of the two objects. However, sometimes it does work out to be the radius. Now, we have two different equations for the force of gravity. I need to know when we use one versus the other. Because we've only had one up until now. Now we have two. We need to understand when we use one versus the other. Carol.
The first one is for objects on Earth.
Okay, rather than on Earth, I'm going to say planet specific, because we could do it on a different planet, we could do it on the moon, something like that. So this one right here is planet specific. Yes, normally it would be the Earth, but it doesn't necessarily have to. So the mass of the object times the acceleration due to gravity is planet specific. Learner.
And the other one's just not universal, so I'll make this worse.
Notice that the one on the right here is one that always works. The truth is, we don't actually need the one on the left. This one is just helps us out because, let's face it, most of the time we're actually standing on a planet, right? So that's what we usually want to use. But we actually don't need this equation. We can always use the force of gravity equals big G m1 m2 over r squared, but we have a handy shorthand for the force of gravity for a planet specific. Great. Ladies and gentlemen, people, thank you very much for learning with me today.